everyone, welcome to this video. Today I want to speak about standard 3D projection. So I will draw a chart. This chart is a visual summary of the main methods used to represent three-dimensional objects on two-dimensional surfaces. It organizes projection techniques into two major categories. The first one is parallel projections and the second one is perspective projections. Parallel projections keep all projection lines parallel to each other. They do not mimic how the human eye sees, but they are excellent for technical accuracy. In the parallel projections, orthographic is the first one and oblique is the second one. Orthographic projection has two branches. The first one is multi-view projection. Show different 2D views of the same object, and the second one is axonometric projection. Shows the object in 3D while keeping scale measurable. Okay, about multi-view projection. This method shows the object from separate flat views. Each view is drawn at true scale with no distortion. You typically see plan view, top view. That here I want to draw a simple plan for you. It has two parts. This is the entrance of the plan and some other details like sofa, coffee table and window on the plan. But I don't want to add more details. Now the second one is elevation view. Front view. Here I want to draw an elevation of some buildings, for instance the first one, and another building next to the first one. And finally the third one that is behind the second one. Some little details on the third building and some trees. Okay, side view, right or left side. These views are arranged using one of two systems. The first one is first angle projection, used mainly in Europe and Asia. The object is imagined between the viewer and the plan. Views are placed opposite their actual direction. For example, the right side view is placed on the left of the front view. And finally, the third angle projection in multi-view projection branch. Used mainly in the United States and Canada, the projection plane is between the viewer and the object, and views are placed in the same direction. For example, right side view goes on the right. The purpose is engineering drawings, manufacturing, blueprints and architecture plans. Now I want to explain you axonometric projection. Axonometric projections show the object in 3D but still use parallel lines. All dimensions can be measured accurately, and there are three types. The first one is isometric projection. In this method, all three axes are equally titled 120 degrees apart. Angles from horizontal are usually 30 degrees, and all dimensions use full scale, most common for technical sketches and CAD. And strength of this method is balanced, easy to draw, and visually clear. The second one is dimetric projection. Two axes share the same angle, and the third is different. Two dimensions use full scale, one uses a reduced scale and looks slightly more realistic than isometric. Strength of this method is good balance between realism and accuracy. So this is full scale. And this one uses reduced scale. The third one in axonometric projection is trimetric projection. All three axes have different angles. All three dimensions may use different scales. Most realistic of the axonometric types, and strength of this method is high realism while still measurable. Okay, until now I spoke about multi-view and axonometric projections. Another branch of parallel projections is oblique. Oblique projections show the front face in true scale and the depth is drawn at an angle, usually 45 degrees. Three types exist. The first one is cabinet projection. Depth is drawn at half scale and it looks more natural than cavalier. Cabinet projection used for furniture design or product sketches. As I said, in oblique projection, the depth is drawn at an angle, 30-degree angle or 45-degree angle. The second one is cavalier projection. In this method, depth is drawn at full scale, and cavalier makes objects look stretched or unrealistic. We can use cavalier for quick sketches where accuracy is more important than realism. The third one and the last one of oblique branch is military projection. In this method, front view is drawn normally, depth is drawn at an angle, often 45 degrees but sometimes scaled, and military projection often used for maps, terrain, and architectural layouts. My dear students, until now, I spoke about all of the branches of parallel projections. And now I want to speak about perspective projections. Another branch of standard 3D projections is perspective drawing. Perspective projections mimic human vision. Lines converge to vanishing points and creating realistic depth in drawing. The first one is one-point perspective, and the second one is two-point perspective. The third one that I want to speak about that is three-point perspective. And finally, when there are more than 3 vanishing points on horizon line, we have multi-point perspective. Okay, for drawing one-point perspective, first of all, I should draw the horizon line. So there is only one vanishing point on the horizon line. So this kind of perspective called one-point perspective. One-point perspective used when looking straight at one face of an object. For drawing roads, hallways, railway tracks, or even buildings, we can use one-point perspective. Here I drew two cubes in one-point perspective that the one of them is below the horizon line. And now it's time to draw two-point perspective. In this type of perspective, there are two vanishing points on the horizon line. So for drawing it, first of all, I should draw the horizon line. Horizon line represents the eye level, and then I should choose two vanishing points on this horizon line. The first one is on the right side and the second one is on the left side. So two-point perspective used when looking at an object from a corner. For instance, these simple cubes. Here I want to draw another cube that is below the horizon line. I should draw all of the lines along the x-axis and y-axis according to the right and left vanishing point. So these two vanishing points are controlling these lines along the x and y-axis. And then I want to draw some hatches for make it more visible and more understandable for you. For drawing buildings, boxes, or room interiors, we can use two-point perspective, and it's a suitable type for drawing these items. And the third one is three-point perspective. There are three vanishing points in this type of perspective, two on the horizon line and one above or below the horizon line. So the third vanishing point isn't on the horizon line. So according to these vanishing points, three-point perspective adds vertical convergence. In this example, as you see, the third vanishing point is below the horizon line. And we can use three-point perspective when looking up at a skyscraper or down from a tall height. And finally, multi-point perspective. So when there are more than three vanishing points in perspective, we called it multi-point. It can be used for complex scenes or dynamic camera angles. Therefore, when you want to illustrate cityscapes, dramatic illustrations, or advanced architectural drawings, you can use multi-point perspective. So as you see, I'm using a specific vanishing point for each part of this drawing here. And this is the multi-point perspective. As a summary for you, this diagram helps you understand how three-dimensional objects can be represented in different ways depending on the purpose. So for show technical accuracy, you can use parallel projections, and for visual realism, you can use perspective projections. Each method has its own rules and applications. Thanks for staying with me until here. Thanks for watching and goodbye.